Hello. So, um, I received this question. Well, this is something that uh, that can be, or might be done by any, achievable among any Form 4 SP and KSSM MS students. And as you can see, these are the equations involving the three variables x, y, and z. However, it's a very funny thing to see that we have four equations. So, according to our experience, to this kind of thumb rule, if we have three variables, then we must have three equations. So if we have four equations, then we must have four variables. So where is the fourth variable? So notice from the first equation, you have the four variable of x, y. It's just a new species. It just combines from the first and the second variable, x and y, and it forms then the xy, which I parameterize it as t, as you can see, this one. Okay? So, how the hell are we going to do this? So, I just tell you my strategies first. So, the first strategy I'm gonna do is I'm gonna solve for each term x, y, and z. Solve for each variable x, y, and z in terms of t, okay, which is in terms of x, y. Like, for example, I use the first equation, 2t minus z equals to 19. And so I can get z equals to 2t minus 19, like so. Okay? And then I'm gonna get for the remaining variables x and y. However, I need to obtain more equations. In this case, I have these two, which are x, y plus 2z equals to 17, and then y plus z over x plus y equals to 5. And I want to choose the third one. Why? Because I can directly get the t. How? Well, as you can see, there's a fraction here. I want to get rid of the fraction by multiplying on both sides with x, okay, which is the denominator of the fraction. So when you multiply on both sides with x, you will get xy at y here, and then you will get 5x on the right hand side. And the xy, as I mentioned earlier, is the t. And because of multiplying with x, your fraction will become y plus z, okay? And hence, you will get something equation like this, which is y plus z equals to 5x minus xy, which I moved them. And then eventually I will get y plus z, and then minus 5x equals to negative xy. It's just a random thing. And then you try to make it more beautiful, that just to ensure that the xy is more, it's just positive. So I just multiply it with each term with -1, and you will get negative y, negative z, and then plus 5x. And then let's have a look at the second one. So the second one, because it doesn't have any xy, okay, which is the t, what you can only do is you just have to pair up with the third equation from with the equation that you have created, which involves the xy, this one. So you just pair this one with this one together, okay? And you will see from here, you will have in total 3 equations. Okay, the first one is what you get from the z, the very first equation. And then the second one, which is when you have manipulated it into the xy, which is the fraction one. And then the third one, which is you just directly take it from the question, and then you will have these 3 equations. So you have three equations with four variables. This is a problem right now. So notice that why don't I actually use the fourth equation? Because the fourth equation is a very special equation that you need to use the values of x, y, and z in order to get the answer. However, it's really tedious for me to find the values of x, y, and z. Instead, I'm going to parameterize x, y, and z in terms of the t, which is in terms of x, y, which is a great thing. Okay, so how I gonna try to get everything? So that's the reason of why I'd actually try to solve for x, y, and z in terms of x, y, which is the t. So I have solved for z, which is z equals to this one, 2t minus 19. And then for x and y, you just try to solve something like for x and y with two equations. So since you have chosen the first one as an equation to solve for z in terms of t, this one, so you must choose 2 and 3 as two equations as the pair equation for solving x and y, as you can see here. But how the hell should I get rid of z? Well, as you can see from the first equation, well, recall back that z equals to 2t minus 19. You just substitute this equation into 2 and 3, and hence you will get, for example, y plus 2 times 2t minus 19 plus x equals to 17, and then negative y minus 2t minus 19 plus 5x equals to xy, which is equivalent to t, which we just parameterize. And then you just solve for x and y in terms of t. And you can use any method like substitution or elimination. Well, in this case, I will suggest you to use elimination. And I achieved these three results, primary results, and I have multiplied them, each of them, with 6. Why? Because when I eliminate y, okay, I have to add the x with the 5x, this one with this one, and you will get 6x, obviously. And I purposely want to try to do the same thing for y and z. Later I will tell you why. So you have solved for each x, y, and z in terms of t, and I just multiply with 6. The first reason is because I noticed that from the elimination I will get 6x, and the second reason is I don't want to have a fraction for the x, for this x, because you multiply, if you divide 6x, this equation, with 6 on each side, you will get minus t over 6 on the right hand side, and this is the thing I do not want. So does it make the equation more complicated? Not really, because you just have transform x, y, and z of these three variables into everything in one variable, which is t, which is a very good thing for me to solve the equation. For example, I can just recall back that t equals to xy. So if you actually multiply this one with this one, and then you will get 6x times 6y equals to 36 minus t, and then times blah 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 minus 23t, and you realize that xy equals to t, then you will have 36t equals to blah 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 something in terms of t, these things. So I've shown you very clearly here, and yeah, you realize something very surprising answer, which is you can actually just solve for t in order to get the values of x, y, and z. So I've obtained t with two answers because you will have a quadratic formula at the end, which are these: t1 equals to a fraction, a mixed fraction, and then t2 equals to 12. Well, let's just try to solve for each x and y. However, I chose not to do so because I just want to try to transform the fourth equation, this one, into the function in terms of t. So that I just have to substitute the value of t, and you will get the question mark answer. Okay, so how? This is the very last strategy I use. Okay, so I copy down here, which is this one, and we'll just try to recall back x. Well, the 6x, as you can see, I divide the 6x with 6, and then 36 minus 6 will be divided by 6 too. So that's why x equals to this one. And then notice that z over z minus y, you can actually just rewrite it instead as 6z over 6 times z minus y, because 6 I multiply on each side of the fraction, each section of the fraction with 6, and you can treat the 6 as a common factor which they might cross out, but I just want to try to add up in, try to multiply with each side with 6, because we just already have the 6y and 6z, and that's the purpose of why I trying to get the function of y and z. Well, I transform the y and z into x, 6y and a 6z, okay, instead of using y and z, okay, and then I can just substitute these these expressions in terms of t, and then you will get something like this, and then the final answer will be this fraction. Okay, and then your desired equation, your question mark answer will be equal to this entire thing, this green entire thing. And t, recall back t, which is equals to xy, equals to 38 and 8 over 23, or t equals to just 12. And you will get immediately two answers. Well, the first one will be the first question mark answer equals to, if you use 38, this one, you will have negative 1708 over 82363, and then the question mark 2 answer, you will get 13 over 2, which is equal to 6.5. And that's all. This is how we're gonna solve for equation in terms of 4 variables and involving 4 equations, which the fourth equation doesn't give any value. Okay, this is the strategy I would like to recall back. So the first one, just parameterize the fourth variable, a very complicated variable, implicit variable xy, in just one variable like t. And then you try to solve for the single variable like x, y, and z in terms of t. And then recall back that the parameterized equation, it just involves the single variables. It's just a combination of single variables, and then you try to utilize them, and then you will solve you're able to solve the t, and then you are able to find the values for x, y, and z, and then you can just get the fourth equation, or alternatively you don't have to really solve for x, y, and z getting the values. Instead of getting the values, we can just actually transform x, y, and z into the functions of t, which is the xy, and then you will get the same answer. And that's all.